Hello. No, Jonathan Blow interview is on Thursday. Tonight is Anton Mikhailov, a regular on this show. Jonathan Blow Thursday. What time? Well, depends on what time zone you're at. It's gonna be evening for European audience and morning before lunch for US audience, and it's gonna be middle of the night for Australia and Japan. In UTC time, it's actually one off, so it's gonna be UTC 5 p.m. But I don't think US engineers like UTC. It's way too much of overhead to change times. We're gonna wait a little bit for Anton. Anton is still has 5 minutes. Yeah, but the schedule for the live stream is today Anton for C++ discussion on state management. Oh, Bennett the First, hello. Where we're gonna walk through a couple of things that may simplify state management in C++ to avoid what is usually happening, which is like a hot patch of every class has a little bit of state for itself, and they sometimes communicate and sometimes not, and sometimes get updated and not notifying other things. Yeah, that's why Anton is pretty much C programmer in C++ world. And I always push him to imagine himself being thrown into a bigger project with tons of legacy and weird stuff introduced by modern C++ programmers. But today that's this session, and on Thursday we have a live interview with Jonathan Blow, mainly about his upcoming game, Sinking Order of the Sinking Star. But as most likely we're gonna sneak in a couple of questions about Jai still. and it's gonna be more about development, less about the game. I feel like other podcasts and other uh, appearances that Jonathan might plan for the game release, they're gonna be more centered around the game. So generally, in terms of Jai access, first of all, you can score points if you don't say Jai and you say the language. Because the whole idea is that Jonathan hates early naming of things. So it's the language, and then you can say trademark or copyright. And yes, I have access. I sent Jonathan a beautiful email a couple of years ago, and he graciously accepted me to the community, which now has like almost 2,000 people. So I assume that if you're willing to do a little bit of spelunking to find out how to get access to the language, most likely you can get it. It's incredibly fast to compile. It's a lot of fun to work within Jai language. That said, the tooling around it and like what you might expect from a language like C++ or Python or JavaScript, where you have IDE and you have everything that like helps you write the code, obviously it's not there because the language syntax even changes from release to release. It's still in beta. So you can preview how it looks like on Jonathan's streams usually. Yes, this is streamed. This is streamed at Twitch, YouTube, and even X. Even X, but I don't think X got a single comment on these streams. I think it works more as a notification because it pops up somewhere. So if somebody sees this on X, they are more willing to go over. Oh, now I realize I have dead chat on YouTube. Of course, and this is like a ton of things. Sorry about that. Hello everyone on YouTube. Somebody said Jonathan Blow hates everything, LOL. That's not the case. He's quick to give you his feeling about stuff, but I don't think that's... No, I guess it's difficult to put yourself in their shoes, to be honest. They are public people, they talk a lot about how things could be, and they always face a lot of criticism for saying stuff off their chest, like directly. I wouldn't be quick to say, like, I don't consider them complainers. I talked to them a couple of times now, and they are always aiming high and they're high spirited usually. It's just that it's difficult to get this nuance on the internet discussions. Hello, Raiken. I wouldn't wish C++ on my worst enemy. The thing is, C++ is great. And Anton is gonna be here to confirm.
I hear you.
1, 2, 3. 1, 2, 3. Did you just woke up? Just wake up.
No. Oh, this sun is crazy. So I actually got a second monitor set up so I can put you over there. Would it
Damn.
look weird if I talk to you like this and then code like this? Is that good?
I think it's gonna be fine.
Okay. The monitor is refusing to turn off.
The sun is crazy, but then again, you're living in sunny California. I'm not at all jealous. I'm not at all pissed. No. But
Too much
also,
sun.
with this sun, like, you know, if you would now Google like how to create a studio that would be nice for recording, the first thing they would tell you it's like avoid direct sunlight.
Yeah, well, we're just gonna have to. Yeah. Let's see. I'm just gonna clear out some stuff and get the code ready. So I have some space.
Is this fish tank in the background?
That's geckos.
Damn.
Yeah.
A lizard guy. A lizard man.
Lizard man. Let me just see what's going on with this monitor. If I can't get it.
Who here in the chat played Warhammer Fantasy Battle? Not Warhammer 40k, okay? Not like the futuristic stuff. The real thing. Before Age of Sigmar. Warhammer Fantasy Battle. Getting the figurines, gluing them together, painting them, and then sitting either on the table or on the floor for like 6 hours to battle through 4k 4,000 points battle. Anyone.
Okay. Monitor's booting up. We're gonna have a second monitor.
No one.
Look at that.
No one is playing. Anton, have you ever like collected figurines like Warhammer 40k or Fantasy Battle or?
I didn't have the money to collect them, but I attempted to collect them. So like, we had a hobby shop near my house, and I didn't know what it was. Like I came from Russia, and I was like, these are just figurines. I didn't know there was like lore and whatever. But I was like, oh, I want some dragons and orcs and stuff. That looks awesome. My parents were like, that's $30. We're not buying that. I was like, oh.
It was ridiculously expensive.
It's stupid.
The other day, like we went, our parents got me and my brother, I mean, 150, 200 zlotys, which was like incredible amount of money. Okay.
Yeah.
But the deal was that we're gonna buy some figurines for us as a sort of a gift or whatever, something, and we got there, and we've already had like probably between like 40 to 60.
Yeah.
And it was wood elves or wooden elves, I don't know in English. So like we had a lot of elves, and like some of them were on horses, and like because this like we actually battled with this, so it was important what kind of characters this is. So we went there, and then we came back with one figurine. Like we bought one, but this was the huge one. This was the Treant. You know, like this was, for us, it was like dream come true. And I even lied to the person that was selling this because it was 160. And I had 450 banknotes. So I hid one and said like, I only have this much. And they sold this one. And I was so happy. And when I saw my dad was like, and then we got
one?
and my mom was furious.
Yeah. I mean, I get it as like a parent. I'm like, oh, this is bananas. But yeah, so I didn't actually get good at painting them or anything. I think that's the actual thing you do, right?
Yeah.
But yeah.
I have tons of them, but I'm not gonna open them now.
Yeah. I'm just gonna close down all my tabs and things. So we're gonna go full screen share, and I don't want to like worry about
People are asking whether Warhammer is good. I don't know about now, but Warhammer, either you love it or you hate it. Because it's so intense. Then like if you have a friend that is into Warhammer, like he'll not shut up about anything else. It's gonna talk about only about Warhammer.
only Warhammer. John Beach at Media Molecule was into Warhammer, so I talked to him, but he was like super good at creating stuff. Like, so yeah, it was like there's some people that are amazing.
This was the painter guy or not?
No, he was John Beach is the one of the game designers there. He's actually from the Little Big Planet community, but he got hired as a designer.
Damn.
And yeah, and he just like is killing it. And so yeah, he was into Warhammer. So he'd make these amazing non-Warhammer, completely non-copyright infringing works and dreams that were amazing and totally unrelated to Warhammer, but they were cool. Yeah, so let's see. I'm just checking my pen. We might actually do some whiteboarding today. Is that crazy?
Okay.
Maybe. I don't
Do
know.
you want to test the screen share beforehand? Because
Yeah, I think so.
probably
There's some stuff going on. All right, let's see. Screen share. Oh yeah, let me just. I should probably move all my crazy icons out of the way.
hello everybody who is joining.
Just about to go. All right,
Your mic is. Can chat confirm that Anton's mic or Anton's volume sort of oscillates, or is it just me?
I think
That
it's
ju-
because I'm moving to do screen share and whatnot. Hopefully, when I'm here, it should be like this. And then when I
Can you
turn,
say something in front, like
this.
staring at one monitor and then the other
Okay,
one?
this
and
is
then...
me talking to the computer, and this is me talking to Mukesh.
Yes, so it's way more silent.
Way different.
Yes.
Shit. Okay. What if I? I don't know if I can do much about that. Otherwise,
Okay,
or
that's
just
fine.
be more conscious about it because I don't think there's any. Is the sound okay right now?
This one is okay.
Now I'm in a weird frame though. Let's see if I can. Can I frame myself better? Is that better? I don't know.
I think it's fine. I think
Okay.
it's fine. Like for the framing, don't worry about it.
Okay. Whoa, that's the wrong screen.
And as usual, please do not share any personal important information. Please.
That's what I was just double checking. All right. And this should be 1080p left to right, so it should be good to cut later, hopefully.
1080p left to right, meaning white to white.
Yeah.
Damn, look at this non-white background. Damn,
Like that?
nice. Nice.
This is the thing we were
Still,
talking about earlier.
still like, ooh, look at this green. Damn.
You like
Awesome.
that? This is serious.
It's
All right.
awesome. Okay.
All right. Yeah, man. So what
Okay,
are we doing
okay.
today?
Exactly. So, tonight we are gathered for Anton to showcase a little bit of state management that is more sane than the usual. What usually happens in C++ projects is every class takes a little bit state itself, hides this in the member, and then through public methods, people change and adapt and write and get the state. And it's just a hot mess of callbacks and updates and notifications and whatever. And it's not gonna be full Dreams PlayStation 4 style of state management, but a halfway there, a more sane version, which I coined the term large arrays of things. Okay,
Okay.
I think this is I think this is the most this is the most marketing oriented term we can coin.
Lats.
Large arrays of things. Louds.
Louts. Sounds nice in German. It sounds like good German engineering, good quality German engineering.
Do you have anything to add to this intro?
Yeah, I guess I'll say that um, that there's like that Tenacious D song, this the tribute, like this is not the greatest song in the world. This is just the tribute. This is gonna be like that. It's gonna be like this is not the greatest engine in the world, but this is the tribute to the greatest engine in the world. So I think it's like you said, it's not quite full dreams because I think honestly that's not needed most of the time, and also you can't code that in a stream. But I think you can code something really close philosophically on one stream. We're gonna try that and see how it goes. It could bomb. We're gonna do workmanship of risk. I did like a little bit of typing earlier, but honestly, not enough to properly prepare. So, and Mukesh's gonna careen me into a place I'm probably not prepared for anyway. So,
I'm not gonna push you today to do full modern C++, by the way.
okay, I'm ready though.
Tonight.
We are gonna do some C++. We're gonna overload some operators.
Ooh.
We're gonna
Okay.
we may use a constructor. I'm not sure. Probably not, but we may. And we may even use references.
Hell yeah, references
So
is
it's gonna be crazy. Maybe the sun will also move, so it's not blinding me. But that just depends on the time of day.
but
Um,
you like light IDEs, so sun is matching.
yeah,
Fitting.
it's just like evening it out.
And
Yeah.
technically speaking, also, we're like planning to go for something between 60 and 90 minutes. We'll see how far we'll get. And this video will later on be, this recording will be later on available for the members immediately in this raw and unedited fashion. Meaning, if you say something outrageous and it will get demonetized or whatever, everything will be recorded and available. And then afterwards, after probably 2026 now, it's gonna be an edited version available, published for everybody to see. So, in terms of questions like what's gonna be, whether this video with Anton is gonna be available anytime soon, it's most likely it's gonna be like 4 weeks plus because it's Christmas, New Year's, people are away, and
Yep.
things take time.
And people need to code their own projects at Christmas time.
Exactly.
Just
And like spend time with family.
yeah, and get rid of the internet, get a cabin, get a laptop, and don't look at the documentation and just write it. How you're gonna write it.
How are you gonna write it if you don't look at documentation?
Well, that's what we're gonna do
Documentation
today.
is the thing.
That's what I'm talking about. So like I think of this as like log cabin development. Like this isn't like we're gonna build a skyscraper or even like a residentially building that's to code. It's more just like, those videos where the dude goes in the wood with like an axe and then he builds like a cabin. Like that's the kind of game slash data engine we're gonna do. So it's kind of designed for small teams of one person. uh, but you can get a lot done, I think, that way and keep your sanity and, make your happy little cabin. So,
This is
yeah.
from scratch game engine development that is supposed to be also a lesson about state management.
Yes. Yeah, because I think we figured we would want to do something concrete, because if we just do state management just abstractly, I think it kind of gets very abstract. So I think we picked like, okay, we'll do like games, even though we're not going to say ECS. This isn't ECS. It's large arrays of things. Okay, we're not going to open the ECS Pandora's box. Or maybe we will. We'll see. So I think, should I put some thoughts down?
Yes.
Yeah.
You can do like a tight comment title at the top.
What's a Oh, you mean like author and all that?
No, it's more like for people who would be joining in to know
Oh, yeah.
at least what are we
Large
working on.
arrays of things. Louds. State management TM. Um, so I think, I won't go into too much into like how people typically do things, especially in C++. I will just sort of just give for context because I think it's the way I arrived at that stuff is just by programming for a long time. And I think when I first kind of got out of university, I sort of made things like this, where it's like I'll have like a class entity, and then I'll have like class player, public entity, and some version thereof, right? And then like my entities maybe have like a protected vec2 position and like float health. And then I'm like, well, not everybody's gonna have health, but most of them will have health. So I'll put it here, and then there will be like class player, and that will be a thing. Let's say we're making like, the classic thing you make in college, which is like an MMORPG, because you just got ambitions of grandeur. So, so we're gonna have players and we're gonna have monsters, right? And then you're like, great, this is working really well. And my players and monsters have like health. And then I'm like, I will also add, weapon. Oh, but my weapons don't have health, but they do have position. So that's kind of annoying. So I guess I need to like add an intermediary class, and it'd be like class healthables, or I don't know, living, and so on, right? And this sort of just grows and grows and grows. Or you might sort of give up, and maybe later on I decided, okay, I'm not gonna do all the deep classes, but I will just say, okay, well, if I have like health, I'll just copy them in here, right? And then, I'll get rid of it here. And then this thing slowly becomes like empty and just becomes a front end, or it just grows needlessly and has crazy methods on it, blah, blah, blah. So we all know this world. So then I was like, okay, this don't work. This is too much stuff, especially for a small game.
And this is like a textbook C++ as well, right? Like at
Yeah.
some point, at some like C++ introduced like with classes, and this inheritance idea was very core
Yeah.
to the whole thing.
That's
Meaning
what I
like,
learned.
hey,
I mean, yeah,
yeah,
I learned Java in college. I didn't learn C++. I just kind of learned it, a bit on the side, making little toy projects and stuff. And this is sort of what we did. I was like, all right. And then I was like, okay, this is kind of crazy. What if, and then someone was like, you should just have an entity class, and then you put all your stuff inside. So you have like, you'll have, entity type, enum or something, or maybe enum class nowadays. We didn't have those back in our day. We didn't have no enum class. So you'd have like entity type, or however you want to do the styling, and then you put your stuff in here. So then you still have your vec2 pause, and then you have your health, and now you have like maybe your float damage for your axe. And then you're like, okay, well, entities, we're gonna have player, we're gonna have monster, we're gonna have weapon, and now you're just sort of switching on stuff. And all is pretty good. And then you're like, why do I even need a class? I don't need getters. And so you just make that a struct. And this is kind of where you get to the fat struct kind of approaches, where you say, we're not going to really have all that stuff. Everything's just going to go in there. And even like the axe will have health. Who cares? And maybe there'll be a talking axe one day, and we'll like be really happy about that because we can have a talking axe.
And if people in the chat know Ryan Fleury, he's like the hardcore member of Team Fat Struct.
Yeah.
Like,
Yeah.
he will go to town for Fat Structs.
Yeah, and I think if I can channel Ryan, I mean, you should read his articles, but they're all great. But I would actually probably channel Ryan further. He would, I don't know, I don't want to speak for him, but I suspect he wouldn't even do this, where you have like a type and then you switch on it. He would probably have something more like, I would call them like traits, and you would have something like positionable, and then enemy, and then like holdable, whatever, and then you have these as flags, right? So you would do something like this kind of stuff, and then with that, So with this kind of approach, then you don't even really have a type. You have like, you have more like, hey, what does this thing do? And then if it's positionable, like then the position matters. And then if it's, you know, an enemy, maybe the position and the health matters. And then you can kind of keep subdividing this and keep going more and more. Or you can do both. You can have like broad classes of like players and monsters and ask, you know, maybe terrain or something, and then more traits. So this is sort of where I would have my starting point. I think this is kind of like a good place. However, one of the things people don't talk too much about is then what do you do when there's like, how do you actually put these somewhere? So, you know, Ryan would put these in an arena or whatever, and then, you know, go from there. But like, what exactly do we do? And I think for a while I kind of did this style, but then I would also make a sort of slight detour and I would be like, well, I want like items, right? So I'm going to have the items that the person's holding, right? So I'd have something like this, or then maybe I would have, and so that you can actually put those in here. But if you put them as like structs in here, that's a little bit problematic because when they fall off like to the ground, you have to pull them out and put them somewhere. And oftentimes the renderer needs to know about them. So actually you probably don't own these things. So you probably actually have a pointer to these things and they live in an arena somewhere, something like that. And then you might have like an entity parent. So maybe you're grabbed by something. So like typical for a weapon or something to get picked up and now it's getting carried around, or maybe you picked up a dead body or something. You're trying to hide it in the closet, whatever it is, the game you're making. So you're going to have these like references to things. And immediately this has like a couple of problems. So one problem is if these are raw pointers, we get the thing that people in the C++ community worry about, which is like, well, what happens when they're null, or what happens when they point somewhere broken, or like, you know, what if somebody deleted your parent and now you're pointing to nothing? How do you fix those up? Do we need to send, you know, messages to this thing to get sorted out, and so on and so forth. So let me just check this really quick. So the problem here is we now have something that may no longer be there. And so we need to deal with that somehow. And so if you're in C++ world, people are like, okay, well, we're going to do shared pointer, right? We're going to do something like that. And now we're going to have this. And then when all these disappear, then it will get automatically cleaned up. And now we're starting to go back into this sort of C++ madness world. And it's not exactly clear how to escape the problems that we just discussed with raw pointers without going into here. So that's one problem. This is kind of lifetime management. And then the second problem is that now we've got like a stud vector inside this entity. Every time it's getting copied around, it's getting moved. That's going to cost you performance, that the cache is sort of unhappy. So these are the two things we hit. Does that make sense so far? Is this all sounding familiar?
Yes, but let's maybe stop right there. First of all, it might not be obvious to everybody that like std vector in C++ is the general list in other languages, or array list in Java, which means that it allocates memory for a couple of objects, like capacity, it's usually called. And if it's at some point, if you append something to it, which would be pushback in C++, if you exceed the capacity, now everything that is inside the vector needs to be copied over to a new place where you would allocate more memory for more objects. So you never know when you hit the capacity, because the idea is that you don't need to care. So and Anton, being like hardcore console programmer, he cares about memory. Or maybe like I didn't want to say that only you need to be hardcore to care about memory. You can care about memory if you're not hardcore as well. But the idea being that you don't want to have this being sort of a ticking bomb of performance. You don't want to have this stored somewhere and grow and you cannot account for it. And also, initially, and without having the state vector here, for example, you had contiguous memory and you had everything in one place. And once you get down to the memory management tricks, you want to have this ability to keep things in one place, because it, when you said keeps cache happy, usually cache works this way that when you're loading something into memory, it takes what you're loading and bytes in front of it. It's called cache line, and everything there remains in the cache. If you have things that are just pointers to places on the heap, if you load just one, you will not get the other things in cache. And you usually load something because you will access a couple of members or properties in the struct. So that's that's the downside of having std vector, at least as far as I'm concerned.
Yeah, and so like this thing I just showed, like if we have this array of these things, now we have a bunch of vectors inside, and each one is going to be pointing to a different place. Maybe we'll switch to a whiteboard later and kind of draw it out. So your memory very quickly is kind of all over the place. I don't know. Do you think we should go to whiteboard for a bit? Maybe we should. You want a
Maybe
whiteboard?
we should.
Let's
Maybe
whiteboard.
we should.
Because the next transformation I was going to talk to probably helps. Flashbang. All right.
It's not that rough when you switch from yellow.
Right. Okay. So let's see. Okay. So what we're talking about is if you have an array of entities, I'm going to just call them things because I don't like entity. It's such a long word and it doesn't mean anything anyway. So
What do you want to call it?
I'm
Thing?
going to call them things because that's what we called it anyway. Large arrays of things.
Yeah.
We're not gonna do the E word. No.
Because it's not ECS, okay? It's not ECS.
So
Please
so
don't say entity component system, please.
So we have our things, right? And so here's our things in memory, and inside them we have like their fields. So I'll do that in maybe I should even go lighter gray. So we have like our stuff, and this is going to be our things like health, position, etc. And then in the next bit of memory, it's going to be the next things stuff. So even if you're inside like a stood vector of things, it's going to look something like this. And when it grows, it does things. But now the problem is that this last thing, so there's two problems. One is that we have this like vector items, right? And this vector items can't like sit in here in a diagonal fashion. That doesn't occur. What actually happens is this thing has a pointer to somewhere else, which contains its own vector of stuff, which are the other things and so on and so forth. And this one, the other things vector of stuff, is going to point somewhere else. It's going to be a different array. And then so on and so forth. Each one of these is going to point to their own array. And if the things inside those arrays have vectors, then there's going to be more vectors. And so now very quickly, all your memory is sort of all over the place. And that means, like Lukash was saying, is that if I hit this piece of memory, all this goes into cache, and the cache is very happy. But then as soon as I go here, it has to load this into cache, and I go into here, loads this into cache. So every time you're cache missing all the time. So that's kind of one issue. And then the other issue is that the other thing that we talked about here, which is the parent pointer, which is like kind of the canonical pointer you need to keep around. Well, that has to point somewhere. So let's say like, let's see, maybe this is like thing 1, and then this is going to be thing 2, and this is thing 3, right? So if the parent of thing 2 is thing 1, then we have something like this where it's like kind of pointing over here. But if thing 1 moves around in memory, that pointer is no longer valid, so that's no good. And so what people often do is they say, well, no, we're not gonna do, an array of things. We're gonna do an array of thing pointers and put those somewhere else. So then that way my pointer, the thing I'm storing here, is not a pointer to this area. It's like a pointer to this area. And it's like all my things are now also going to be separate. And that way they can sit in some sort of location in memory, and we'll point to those things. And now there's no kind of problem with them moving. They can still disappear. So very quickly, this whole thing balloons into this memory soup. So how do we not balloon it? The trick is this thing called an intrusive list or an intrusive tree. I don't know if people are familiar with the concept, but the idea is like, wouldn't it be cool if this struct thing didn't have these dynamic things in it? Can we just like, because the other problem we didn't even get to, but as soon as you put these kinds of things, whether it's a stood vector or an array, I mean, array is less so. The array has to have a size. Basically, the point is you can't zero initialize this stuff. You can't just move it around. Now these things need constructors, all that jazz. So really, we don't like want this, but we do want something for parent, and then we want something for items. And so we need some way of having that stuff work. So the idea is, what if we use indices? So like we've got this array of things. So we will use thing IDX. So we can say this is like parent IDX. Okay, and thing index can just be, for now, it could just be an int, but we can kind of get more serious with it. Well, if we make it an integer, then we can point to a point place in the list. We still have to deal with what happens when it moves, but at least when the memory gets reallocated by the vector or something, or whatever grows, now we don't have to like worry about the pointer disappearing. Does that make sense? Like, because you were saying when the other problem is every time the vector reallocates, it reallocates the memory, so your pointers get invalidated regardless. But an index won't get invalidated. So now at least you can be stable for the reallocation. So that's an improvement. And we'll talk about what to do with the other things later. But then this items thing's weird. Like, how do we actually do an array? And the thing to note here is that there's this is kind of a subtle point, but there's only one of every thing. And so when we did this kind of thing,
This is getting philosophical.
this is gonna
quick.
get philosophical a little bit. But here we've made a vector of items inside, and this thing owns all those things. But really, there's just items. There's like axes and potions and trees and whatever. And we only care as the sort of owner of these things about the first one. So actually, if we reframe it and we say, okay, we're going to have thing IDX first item, we're like implementing inventory. And we don't know where the second item is. We don't really need to know. We just know where our first item is. And then later on, the other item knows the next item. And so this one is like the first item we own. And then this one is the sibling item to ourselves. Yeah. And we could talk, I don't know if it's easier to, well, yeah, let's do this, and then we'll do trees, because they'll be cool. Okay. So with this thing, I don't know if I should delete this or just hide it. What do you?
You should delete it.
Delete it. Okay.
Or maybe throw it somewhere below so that we can sort of compare it to what it was before.
Okay.
At some point, but like to get rid of from the screen. Yeah.
Yeah, I probably should have. Oh, you know what we should do? This is crazy. I have an idea. Okay.
I'm worried.
We're gonna do it. Okay.
I'm concerned.
Save. Good. And then we're gonna use the power of undo. We'll bring the monstrosities back. Oh God, what is that? What's that? What's sub?
It happened in the first stream as well.
Okay.
There's this sub.
Oh well.
Character.
Well, we didn't lose it. Anyway, we can put those back in there. There. Anyway, we'll figure it out.
So for people who are joining in and might be confused, we talk about large arrays of things, which is a now coined term for state management that doesn't suck. Okay, which means that you have lots of things that you need to store for any kind of application. Basically, you write an application to have something happen for many objects, because if it would happen, it should happen only for one, then you would do it manually and you wouldn't write a program. So whenever you're doing, either it's a game and you want to draw many things, or you're making a blender and you want to have more triangles or nodes in your node management system, or you're taking writing your version of Obsidian nodes and you have tons of nodes, anything, pretty much anything that you do, or it's UI nodes, anything,
Mm-hmm.
you end up having things and you need to store them somehow in a way that makes sense. And in C++, there's tons of things to do to achieve every little thing. And most of them are not necessarily compatible with each other, nor even make sense. And here we're trying to use Anton's Dreams experience, which is a game he worked on while being at Media Molecule, but also in general experience, to end up with a state management system that has things laid out in memory quite nicely. So has these properties of like being friendly to cache, not having tons of pointers that you jump through, which would happen if you have things like std vector or just raw pointers inside the struct of the memory. So we end up with having an array of things, not entities, but things. And now we discuss how we change a pointer to the parent and vector of items or anything that you could imagine, that multiplicity, one thing that should hold multiplicity of other things, how to change them so that we end up with this nice memory friendly layout that you can manage easily in terms of lifetimes.
Yeah, and it's gonna be also safer to boot. So it's not
Damn.
even, we're not even gonna sacrifice safety, I think. And we're not even gonna sacrifice convenience. But we will sacrifice some things and we can discuss it, whether they matter or not. But I think a lot of times people are like, well, you can do this memory stuff, but then you lose safety and it's annoying to program and all these things. And you have to, like, no, you don't actually, we're not even going to optimize that hard. And we're still going to be safe and fast. It's just going to be great. It's going to be great if we
Everything's
get
gonna
there.
be great.
If we get
So
there.
now you talked about changing the
Yeah.
pointer to parent
Mm-hmm.
into a ID for the parent, which
Yeah.
makes sense, right?
Makes sense. That's like the easiest transformation we can think about. The one that this is trickier is like, what do we do with these things that might hold multiple things? So let's go back to imagining that we just have one flat array. And let's forget about the properties because they're, you know, like the health and the damage and all that stuff. We don't, those are easy, right? And I think nobody really worries about those very much. Let's talk more about just like these parent pointer things and also the vector. And so what I said is before we had these vectors that pointed to other blah, blah, blah. And we're like, okay, first thing, we got to get rid of the pointers. The pointers are unsafe. They also don't serialize.
Unsafe.
Unsafe space. So we don't want them. And we might bring them back later because I'm not like, I'm very pro pointer, but you know, people are right. This is not really, you don't really want to be storing raw pointers in structs, partly because serializing will become sucky later. We're also, by the way, going to make this thing serialized like trivially. So it's going to be even good on that front. Okay. So let's think about like you know, we have our data members or whatever, and then this one is going to be our parent, and this one's going to be our items. So these last sort of like two things. Yeah. And so we already did our indices. So let's do our parent pointers. What color should the parent be, Wakash? What's a good parent color? Red? Red.
Red is
Parents are
like,
the law.
yeah, exactly.
That's right. So some things will have no parent. So if you have nothing, then you'll just have a zero index. Um, we will for the well, I'll skip over that, but for this reason, we will actually start our arrays at 1, and the zero entry will be reserved for a special nil value. So then 0 is not a valid index anymore. So some parents are going to point somewhere else. So for example, this one might point to this index, but pointing is not even the right word because really P is just going to be 1. And then this one, maybe P is 3, right? So like 1, 2, 3. So it points, well, maybe let's make it 4, let's make it 5. So it points to the right. So like you can kind of imagine it pointing here. But again, they're not pointers, they're just indices, right? Okay, but what do we do with these item lists? So items are going to be green. So let's say this first entry here has, let's say this is like an axe, and then this is a potion. And so what I just said is that we're going to have a first, and let's might as well label the numbers. 1, 2, 3, 4, 5, 6. Okay. So I said we're going to keep this first item thing. Windows, you're drunk. Okay, first item. So first item is now going to point at 5 because we're holding the axe. So it'll be a 5 here. And effectively, it's going to look like this. But how do we get to the next item? Well, the actual item has another entry, which is the next item. And so here, the next item is 0 because there is no next item to this one. But here, the next item is going to be 6. So we put a linked list into the array itself. So this is the way linked lists work, right? You just keep pointing to the next thing. But this is an instance of what's called an intrusive list, which kind of fell out of fashion, but it's all over the Linux kernel, I guess because it's all C. But the idea is that in C++, you typically, the way you do a C++ list is you do this, right? You have your list of things. And the list is what manages the pointers and all of that stuff, right? But because of that, a curious thing occurs, which is like your thing can be very simple, but now your list is pretty complicated. And it means that you can no longer copy it, you can no longer serialize it trivially, all this stuff. And because you've moved all the machinery of listness into the list, but you don't have to do it that way. This is your own happy little cabin. You don't have to do it that way. So we're going to just put the list into the thing, because why not? And so what that lets you do is you set up this intrusive data structure, which means now all of your nodes or your things are fixed size and they have no allocations inside them, and your lists live inside. That's all there is to it. And so when you manage those lists, you manage them inside what we'll call things later. So there's another. Yeah, go ahead.
Intrusive in the name stands for we're de facto defining list as part of the thing itself. So like we sort of adapt the definition of a thing that we're gonna store to have pointers to next items.
That's right. So it's intruding into the data which you're storing.
Okay.
And what's interesting about this is that it works hierarchically. If your items have further items, it will just be more of this. At no point do we need to go into this world. So here the problem is every time you go down a nesting, you actually add one more indirection. Here, we never leave this array. We stay in it the entire time.
And here, the red ones are parents and the green ones are items or anything that you can hold or whatever. And this list can express all sorts of weird edge cases. Meaning like, first of all, you can have no next item, right?
Which is fine. That's the end of the list. Or rather, yeah, it's the end of your list. So like, for example, the potion being the last item will have a 0 next item because that's the last one.
What about the first if you have a first thing
Uh-huh.
and it has 0 items,
That's okay. You'll just have one thing. So for
but
example,
if what would be in the ID slot for items for the next
just a
item?
0.
Okay, so you would point to this like first nil element.
Yeah, and we'll actually in the end we won't it's not really pointing to the nil as much as this you could think of, I mean, this gets like into hardcore category type theory stuff, which I think I'm not that versed in, but I think this is where people get mired in thinking like, what does it mean to point to the nil? Like it's just a 0. The 0 means there's no more stuff. Just it's no more stuff.
Just get over it.
Just get over it, man. But you'll see in code, it will work out that 0 just means there's no more stuff. And the sort of foreshadowing will be that if you dereference the no more stuff, you're not going to crash. That's the advantage. Because
Oh,
if you use traditional null pointers, if you forget to check the null, you're just going to crash out. And the other place where you can get a null is when you run out of memory or when there's not enough memory, you get a null and you have to check the null or you crash out. So we're going to like just sidestep that whole thing and we're not going to crash. We won't do anything good, but we won't crash, which is good for software, I reckon. So, and we'll morph into that. But maybe I'll draw another diagram which will make a bit more sense, because when I'm drawing it inside the array, it's a little bit messy. But think of it in terms of just a tree of things. So let's say this is our node. This is going to be the root of our tree. This is our scene graph, for example. And so we go here and we have our player, edge of world. And the player is going to contain the items here. So it's going to point to a first item, which is like the axe. And the axe is going to point to the potion. So that's going to be the actual structure here. Now, potion will also have a back pointer to the parent via its parent pointer, and so will axe. But as this list expands, parent cannot access, like let's say there's, I don't know, food. Food is going to know that its parent is this guy, because everybody gets a parent pointer. But
yep.
for parent to be able to look over its items, it needs to do a list iteration. So it will have to do like a standard forward linked list traversal. So that's the thing you lose. You lose random access of your children. But from all the years of writing tree data structures and scene graphs, it's extremely rare that you're going to be like, I want the third child. It's never that. It's always like, iterate my kids. Who's the axe, right? And so you're going to iterate anyway, right? And the other thing is, okay, that little bit of memory is in order. It's like, oh, you can iterate really quickly. It's like, who cares? You're iterating like 3 things or 10 things in your inventory or whatever, right? That's not going to be your bottleneck. The bottleneck is going to be iterating all the things in one, which is now all over the place. So you've sort of like lost the forest for the trees. So as this list grows, so, we can kind of get into the actual, performance analysis later if you want as well. So right now, when you add things, you add it to the end. So it's the same cost as a linked list. You have to do a traversal, add it to the end. There's actually a way to solve those things and make the addition fast and removal fast and all this stuff. But this is what the data structure looks like. So unlike a typical tree, which sort of looks like, you have your parent and then you have your kids, these trees, the intrusive trees, have more of this look where they kind of go, and this one might have something like that, and then like another one. So it's kind of like trees of lists, and these things might have another list that hangs off of them. So they look like a little bit different just when you draw them. In practice, they don't.
Yeah, when you draw them. Because
When you
like,
draw them.
In my head, they still fit in the array.
The
nicely
hierarchies.
because they're there.
That's
Okay,
right.
but
And the hierarchy is still this. It's just in one case you express it as a vector, and in this case you express it as an intrusive list. And there are actually back pointers. It's just in this case, there's actually bidirectional pointers. You know your parent and each individual kid. So if we were to draw it as a proper DAG, it would be back pointers. In this version, there's only pointers up to the parent and a pointer to the first child. So it's interesting from a sort of actually a correctness standpoint is that this version that I'm showing, the intrusive list versions, is actually fundamentally more true to the state of the system. Meaning that the invariant you uphold is that there will always be one axe. This is the axe. You can't put an axe into an inventory and have still an axe on the ground by accident. You just that's not an error you can have anymore because you're not adding it to any other list. It's just here. You're just tweaking the pointers. Okay, before it was like the ground owned the axe because it was on the ground, and now the parent owns the person owns the player. But there's no more of this intermediary state which you can mess up, which is like, oh, the axe is in the inventory and on the ground. That's weird. So you know those classes of bugs where it's like the Diablo loot duping bugs and all this stuff, right? Doesn't exist, right? It can only be in one place. So that's a place where people are like, well, in a way, the intrusive list is more true to the state. And like, I very much believe most problems arise from incorrect states. Like if you just think of your program as all the possible states the thing can be in, if you reduce those, like bugs are effectively states that are not part of the specification of your program. So this is an actual technique where you can on paper see it's reducing invalid states. If you don't want something in two places, it now literally cannot be in two places by construction. So you can still have wacky things where maybe you added it to the list, but the parent is here. So you could have errors of that nature. But typically you have just one function, which is like add item, and you won't have access to this node to make that incorrect linkage. So it's pretty unlikely. But so it's not like it reduces all invalid states, but it reduces some classes of them.
And usually you would have just one parent, right?
Mm-hmm.
Like for the parents, it would be just one. But you can have multiple next pointers for next things. Or is this not the case?
Well, every one thing, I mean, if we're talking about inventory, just to be specific, so next, we're going to say this is like first inventory. So this is implementing literally the inventory list. And so the thing that's a little bit of a brain thing is that the first inventory item, this belongs to the inventory owner. So this is like your player, right? So like player is going to have this thing.
Yeah.
But this next inventory item belongs to the item.
Yes.
So this is like axe food. So they're like, it's weird that both of them are in the same place. And when you're looking at the parent or like the player, you're like, oh, but what is next inventory set to? Well, it doesn't because the player is not in an inventory. The player is going to be in the scene, but the player is not in anybody's inventory unless we're making like Pokemon or something. Then maybe monsters are in the inventory. I don't know. So if we're doing a generic tree, yes, the player, if we're doing a generic tree, I would actually do something like parent IDX, I would do thing IDX, I would do first child, and then next sibling. So that makes it more clear. And so the tree node does not have a first sibling. It has a first child, and then the siblings have a next sibling. And then if you want to add quick addition to the end of the list, so you don't have to walk the list. So either you can insert at the beginning of the list, which is O of 1. If you want to insert at the end of the list, you do thing IDX, last sibling IDX, or last child IDX, sorry. And then you can do the sort of pointer surgery to get that working. So then you can insert at the end of the list quickly. And then if you want to iterate backwards, same thing as like previous sibling IDX. So if you want to iterate quickly forward and back, you can have previous sibling IDX. And there's some tricks in there. You don't actually need last child. If your list is circular, your previous sibling of the first child is the last child because it's in a circle. And so you can get rid of,
Second.
I'll draw it. So here's the trick you can do. So you're like, so let's say you've got a parent and then you've got your list. And you're like, man, this list is long and I want to add to the end. I don't want to like go first, next, add. That
Yeah.
sucks. So you're like, I know what I'll do. I'll add a link to the last element, or I guess in this case it would be here. And that way, when I need to add to the end, I'm just going to use this last link to jump to it, add my extra element, and then I'm going to, reconnect it to there, right? So now that'll be my new last. And that's a quick way of implementing addition on the end. And so if you need that, that'll be pretty cool. You're like, oh, that's great. But then you're like, well, sometimes I want to go backwards. Sometimes I want to like iterate things in reverse order, or sometimes I get to an item and I want to look backwards one to like delete it or whatever.
Yeah.
So then you're like, okay, well, I have this pointer to last. And then I'm like, I'm going to need to do previous pointers everywhere like this. So now I can walk back and forward. It's a doubly linked list, right? But then what happens on the first one? We're like, well, the first one's just 0. It's like it points to nothing, right? Because there is no previous. And the last one is just, the next one is just 0 because that's the end of the list. But wait a minute. What if we do this? And then what happens is the next item of the last is the first, and the previous item of the first is the last. And then you're like, why would you do this? This is crazy. This is stupid. Because, and now I have to like, how do I even know where to stop, man? I don't know where to stop.
Yes.
I can't figure it out. But note that you're like, just walk with me here. So we have first child, and you're like, cool, I got my first child, next sibling, previous sibling, great. And then I'm like, thing IDX, last child IDX. This is what's making me like addition at end easy, right? And then this one is doing, forward, backward, traverse. Okay, but do we need them both? Because again, state reduction. State reduction is the glorious virtuousness of it all. Well, it turns out that first child, previous sibling, is exactly last child, right?
People in the chat are already saying first is a social construct.
So this is true, right? So this is redundant. We have a data redundancy.
First child, previous sibling.
Yeah, so you go down to first child and you go previous
sibling.
That's your last child.
Yes. Okay.
That's your last child. So why do we need last child? We don't need it. We don't need it. It's gone. And so if you want an easy access of something, you can do, thing IDX, last child, and you can just do first child, prev sibling. I'm being loose here. This is not actually what you write, but something of this lines, right? And you've now computed something that is sort of derived data from something that is the truth. Now, if you didn't have a back pointer, if you didn't have the previous pointer, then, go right ahead, have a last child pointer. But otherwise, it's just like more stuff for you to manage, because now you're like having to manage the last child and the previous child. So then you're like, okay, how do I loop this thing? This thing's not gonna loop because I don't know where to stop. Usually when I write my loop, it's like while node, do stuff, node.
While node is not null.
Right? And then this is no good. And then, node equals node next sibling. But this will never be this will never fail. So now I'm looping forever. Well, don't do that, man. Don't do that. Do node not equal first child. How do you get first child? Well, you have a parent. While node not equal to parent first child, job done. And you can loop. And then you're like, well, but that's going to terminate at the first iteration. Yeah, that's true. So you have to rearrange your loop. So you have to do while node not equal parent first
do
child.
while.
And then, and then you do.
Okay,
And there's other ways. But
I gotta be honest.
yeah,
I lost the thread of thought, the chain of thought
you lost the
at the
plot.
ring buffer, at the
Yes,
at the looping.
at the
Okay,
looping.
why would I need that? Just to avoid the last child uh,
Yes.
index?
um,
Just for this? This weird
well,
trick just for this?
it's not. Well, there's a couple of things. One is there's going to be a theme here, which is that it's you want to reduce invalid states, and having an invalid a zero previous index is a state you can fall into. Be like, I have an item, check the previous. Like what I ultimately want to do, and this is maybe the context you need. So it's like void my game, right? I want to be like thing, first child, next sibling, health equals 30. And I don't want that to crash ever, because crashing is bad. And also because like it ought to not, right? And so if any of these things are null, we have to do something. We can avoid that later and we'll actually figure that stuff out too. But it's kind of cool when state is minimized. So maybe this is a flavor thing, but I'm basically saying like, look, if you're gonna already have back pointers and you're gonna have a last child, you can save your space. Now, there's a performance aspect here, which is the smaller the struct is, the more likely it'll fit in cache cleanly. So removing things is sort of a virtue. But just in
I
yeah,
understand in generality,
yeah,
like
yeah.
that's the good
But why are we
direction.
doing
But
this
like
here? We don't need to. Yeah, we don't need to. It's too
yeah, so
crazy.
specifically in this case, this would
Yes.
be to remove the last child index, and that's
Yes,
it.
this would be to do that. And then also there are some algorithms when it like in UI, I found it oftentimes convenient. Like if you have a list of items, oftentimes if you just want to write previous and next, you just want that to be valid and you don't have to do null checks. Because this thing I just wrote, like let's say I have a node. It's nice to be able to say node prev equals blah, or node prev x equals 5 or something. Without that, you have to say if node prev, then node prev x equals 5. Otherwise, I don't know, like do something, I guess, like don't do anything, maybe, well, in the case that you do want the last item, right? Let's imagine that you have a circular list of like values 1, 2, 3, 4, 5 or something, right? Let's say what I want is that I want to do something based on the prior value of everything. Like let's say it's a polygon, right? A typical case of this is let's say I have like a closed polygon, right? And so I'm looping the vertices and I want to look at like this vertex and I want to draw a line to the next vertex, right? So let's say I'm trying to draw lines with arrows. So this is what I want to do.
Okay.
This happens a lot in stuff that I write for some reason. So let's say I want to draw this red diagram. I have my polygon, right? And so the way I would typically write that is, for in I equals 0, I less than 5, num points plus I, and then I'm like, draw arrow from things I to things I plus
Okay.
1, right? And then you're like, oops, that's going to crash at the end of your list,
Yeah.
right?
Okay.
But if I write it in my way, the next is just going to give you the first, and magically.
Okay, I feel like that's a bit contrived example, no?
This one, I do this all the time. Don't you
For all
do this? Don't you draw polygons all the time?
draw arrows, like
Well, it
more
doesn't even have to
arrows.
be an arrow. It could be a line, right? Because in practice, when you have a closed polygon structure like this, if you don't do this kind of like end of edge handling, you're just gonna get these 4 lines. You're just gonna not get anything here, right?
Yeah, I agree that if you're doing something for like a collection of items, when some the one item points to a next one, often you need this like handle the
Yes.
last case, right?
Yeah.
Which you would be like, oh, you can
Hmm.
crash here and you need to go to the zeroth element. So
Hmm.
this I agree.
So in all those cases, gone,
Yeah.
disappeared. No more. No more
Okay.
bugs. It's great. But yeah,
Okay.
no, it does mean that like when you're inserting elements, you have to be a bit more careful about make sure your forward and back pointers and everything are done. But usually that's a one function where you write it once and then you do it right and then it's done. It's not like terribly complicated. But then everywhere you use it, you don't have those edge cases. So again, it's like these edge cases, like you bump into edges of memory, edges of arrays. Can we get rid of those edge cases so when we write the code, it naturally does the right thing? And if you don't want to go loop around, you can always stop at the end because you have last child here. It's right there.
Yes. Okay.
You can compute it on the fly.
Let's take a tiny break here now.
Yes. Yes.
Uh, if people in the audience have questions, now is the time to like at me with the question because I couldn't keep up during the explanation and like there's a secondary explanation on YouTube and a tertiary, um, tertiary explanation on Twitch. We even got like I think it's Czech. So in Czech currency, Czech korona donation live for this for this explanation of intrusive lists. So thank you very much, Tamkish. So if people have questions, at me, and in the meantime, we can again explain what is happening here. All we want is a large array of things that we keep in memory and we can easily traverse for most things as a state, like a bedrock of our state management system. And we got rid of the std vector and pointers to parents to reduce the hops that we need to do to keep things nicely in memory. We have now identifiers, and through the trick of intrusive lists, we embed next sibling and children indices because it's not pointers. Yes. So we have a little bit complicated thing to like explain. Actually, can you go back to the struct view and then walk through again one more time
Yeah.
all the thing IDX, and in the
Yeah. So
meantime I will
we
gather
have
the questions.
yeah. So we have this idea called thing IDX, which is just an integer for now, which is an index into our one array of things. Our things is literally just an array of max things. And so we have single references, for example, like a parent, which points to the parent. We have list kinds of references, which we were using inventory to discuss. And those require like a first and next at a minimum. You may want previous if you want to traverse the list backwards quickly. And you may want last child to be able to append to the end of the list quickly, but typically you can just append to the front of the list quickly, and if the order doesn't matter. And then if you're going to do a tree, for example, for like a scene graph or any kind of like UI nodes or any kind of node-ish thing, then you need to go full tree, at which point typically what I do is I do parent index, first child, next sibling, previous sibling, because that gives you like really solid traversal and insertion speed and all this stuff. And then we talked about this one weird trick where you don't need last child if you make your children list circular. You don't got to do it. You can have a last child and have one more member. Also, if for whatever reason your list of kids doesn't want to be circular, I was trying to convince Wookash that it's often a good idea, but he's not convinced. But that's all right. It could be your happy cabin, and you can have last child. And if you find yourself butting up against the edges of arrays and being like, oh, at the end do something special, or at the beginning do something special, consider the circular thing. Just have it in the back of your mind. Be like, you know what? If the circular was here, would that remove an if? If you can remove an if, that's a good day. That is a good day.
Yeah, let it grow. Let it grow in him. Okay, for the questions now.
Mm-hmm.
If we have the parent and first child,
Mm-hmm.
IDX, why do we still have the next child in our struct if it's owned by the first?
You need, so this struct is going to be the one struct that rules them all. So everybody gets all of these things. And so in the diagram that we showed, the first child, for example, from the player, points to the axe. So that first inventory item of the player goes into the axe. But then the next child, we have an endless list of these. You can have as many as you want. So, we can't, the whole idea is that this is fixed size. So we can't have like an infinity number of kids in here. So instead, we essentially delegate the question of who's the next one to the item itself. So instead of the parent holding the next item, it's the child that holds the next item. So in practice, what this looks like is the parent has first item, like this link is first item. And then this link is next item. And it's owned by the axe, and then the potion will have another next item. So it's because every node can only have one link. So the node effectively chooses, am I going to link to something that I call a child? Am I going to link to something that I call a sibling? And so on. And everybody just has parents to kind of keep things
But
safe.
if the first have link to the second, then why should the parent have a link as well?
Well, the parent needs to know where the children are in general. Now, it's a good point though. Actually, if you want to go full lean, you don't actually need the first item link. You can establish it dynamically because these items know who their parent is. So actually, in one of the UI systems that I wrote, there was just parent pointers for the actual structure because I never needed to look at the kids during the algorithm. Like it always just added kids. It added kids by saying, my parent is this, work it out. I don't care. Like the parent didn't know who the kids were. It's just the kids knew who the parent was. And right before rendering, I established these pointers dynamically. So as I looped, you can actually collect the kids of any given parent because of the iteration order. So it's true that in some sense, the first child is redundant. It's just if you look at a given parent, if you want to do this kind of stuff where, you have node, if in your code you have some node, it's like void update node, again, being loose with the pointers, we're not actually having pointers, but if you have like, if you want to be able to do who are my kids, then you need a first child. And then, so here's another way of saying it. First child is equal to node first child. Second child is equal to node first child next sibling. Maybe this actually helps to write it out. Third child
Yeah, I think it's a bit confusing at first, but you need to spend some time with it and like work through examples to get it.
Yeah, and pro tip, you can rename children to kids and siblings to sibs, and then everything lines up. If you want to go really drop the readability, but keep the
sib
sib
from sub to
kids
sib.
and sibs.
Okay, next question. When would you reach for linked list approach versus going simpler with parent ID only? I would imagine under some size, parent ID only would be preferred.
Yeah, if you're trying to really just keep these structures super duper lean, usually you're not doing fat struct at that point. You're like, I'm just gonna have like 3 variables and like a parent. If you're doing that kind of thing, then maybe you drop these and then you You still need them later if you want to do any traversal down the tree, but maybe you only traverse up the tree. I don't know. Yeah.
Does this array allow for our things to have dynamic fields, like assigning different components to entities?
Good question. No, but you can. We can get into it. I wasn't going to, but we could try. That's closer to what Dreams does. So I actually don't fully remember, but I think in so I have these things. So okay, what will I say? Okay, so a couple of simple observations. So one is just talking about size. Okay, so let's say, okay, so it's a vector two, right? That's two floats. So one number is, okay, like number size is 4 bytes, right?
Is not uh how is it called when you resize the window and it adapts
Oh,
to the
no, it
is it
won't. No, it's too small. It just gets bigger.
mm,
Um,
it's
I'm
barely visible on my
barely
end, I
visible.
don't.
Okay, I'll just do the calculation just to say the point.
Okay.
But basically what I'm doing is like back of the napkin of how much memory you're gonna deal with for your properties, just to kind of get a sense for it. So if each number is like 4 bytes, right? And then a typical property is like number size times 4. So it's like, 4 color components or 4 vector components, like pretty decent, right? Maybe there's matrices, but typically 4, right? And let's say each of your things is going to have like, I don't know, how many properties do we want? 100? Okay. So then thing count, how many do we want? Like 10,000 things is a good number of things. So we have thing count times property count times property size. So we have that many bytes and divided by 1024 times 1024. We're talking about 15 megabytes of data if you have 100 properties that are a float 4. Okay, so let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's what it looks like. If you have this many properties, right, for your
What
game,
is happening?
right? So that's what 100 properties looks like. I'm just trying to give like a sense, right? So that's how many, that's what it would be like if you had 100 properties in your game. So these are getting to be, this is, I guess my point is this is a pretty complex game that you're probably writing by yourself in the woods over Christmas, right? Because that's the context. So you got 100 properties, you have 10,000 things, and you're spending 15 megabytes. It just ain't worth it trying to do something more complicated. This is like Ryan's point about fat structs. 15 megs for a hobby game, you're all good. You can have 100,000 things and you're spending 150 megabytes. And you can say you can have 1,000 properties and you're spending 1.5 gigabytes, which is, come on, man, potato computer. That's just RAM. You're going to be completely bottlenecked by something else if you've got 1,000 properties and 100,000 things. So that's just to say, one totally valid approach is don't do dynamically allocated properties. For everything, just have all the properties. And if you don't use them, don't use them. No big deal. Sometimes you might find yourself in a position where you do want to reuse them in funny ways, like maybe all of a sudden your weapons have a health because there's damage and repairs that you have to do or whatever. So I guess my point is like, if you do the back of the napkin for your particular game or your particular use case, try that first and just see how bad is it if I just have everything types properties. And oftentimes it's not so bad. We ship Dreams effectively almost on that mentality. Now, the next thing you can do to kind of mitigate it, if you really want to get careful, you can put a union in here. So you just do union, I call it big data typically. So these are going to be my big things. So this is like my big player data, and then just call it player data. And then my big monster data. So this way, you only pay the cost of that kind of thing. That's if you're talking about cost. Now, if you're talking about truly dynamically adding properties on the fly. So for example, you're like, anyway,
Anton, we like there's tons of questions and
sorry,
there's the stuff you need to do. Like,
sorry. Yes. Okay. So moral of the story, you could just do a char buffer, 1024 bytes, custom data. That's the end goal if you really want to get super spicy. But typically, I would say just put your properties in the thing and don't worry about dynamic stuff too much. But we can talk more about dynamic.
okay, there's one question that I think is interesting and might be quick, and I think we gotta move on to reach the true end of
The
today's
true
episode.
ending, the best ending.
This system implies that deactivated objects are empty gaps in the main thing array, right? Question mark.
Yes.
Nice.
So we'll get to that next. What to do about that?
How do we handle the case when the code accidentally accesses the index 0?
We'll get to that.
Okay, there's more. There's more questions, but I think for the flow of the episode, we should move on
Okay.
and continue.
Okay. So for the simple thing today, I'm gonna get rid of the tree stuff because it's it's a thing. Let's just put a checkboard. We can make trees if we need them. I'm actually not even gonna do this stuff for now because we can come back to it. So I don't think we'll get to like actually doing lists, but we can return to it later if we need to. So let's talk about like actually putting things into this array, because that's kind of the next interesting thing. And then we'll talk about the references and how to handle that. Does that sound good?
Yes. Can you say it again? Like, what do you mean actually putting things into the array?
Okay, yes. So we're gonna have where I'm headed, right, is that we're gonna have some kind of like initialization, right? And I'm gonna have static things. Okay, so I'm gonna have this like global variable that's gonna be global to the file, and we want to be able to do things like things.add kind player, right? So where's our kind? Here's our kinds, right? So here's like the kinds of things we might have. We might have player. In fact, let's just stick to like, since we're not doing items, we'll just do like, we'll have trolls, goblins. It's like the internet here. If people have ideas for the kinds of things we want to talk about, drop them in the chat and we can add kinds. But effectively, I want to do something like this, right? This is what I'm gunning for. Meta Horizon link. No, I just got hit with a driver from Meta. Thanks, Meta. So I want to be able to add a player. Like, how do I add? So this is going to be my game initializing, right? And I'm going to do void game update. So I want to move my player around. So like I want to add a player and move it, and then I might want to like things.add kind troll, and then I want the troll to do stuff and move around and maybe hunt me or hunt other things. So how do we talk about properties? How do we talk about stuff? So I want this add thing. So the simplest way of doing that, we'll add a method, and we allocate for max things. We can talk about max static allocation later, but let's just say for now we're just gonna have 1024 things. Okay, and we're gonna have an integer which is like next empty slot. So this thing I'm making, by the way, is sometimes called a slot map. Sometimes people call it an entity pool, something like that. But regardless, we're going to have a next empty slot. And actually, we're going to put it at 1, foreshadowing. 0 slot equals sentinel value nil. And so we're actually going to add a kind of thing, which is a nil. And nil is like another thing people use for null. It's kind of like a null, but it exists. I don't know. I mean, there's probably smarter things to say about that. But nils are different from nulls in that null is like typically a crash, but if you access a nil, it's typically like a zero-ish value. So like ZII vibes. And the other thing I want is I want game reset. I want this. I want to be able to just be like things equal. Like I just want to ZII all my things. That's so much to ask for. I don't want to construct my things. I'm just gonna ZII them.
You hate constructors.
I don't want to.
Yeah,
I don't
hate
want to
them.
construct. Now, this conflicts with it a little bit, so maybe we won't quite get there. So we might have to settle for like, you know, things equals things for now, but we can get to other places later. Okay, so add. So if next empty slot is less than max things, we can simply, well, there's a better way of doing it. Let's just say like thing IDX slot. So we're going to try to figure out which slot we're going to go into. And if we can get a slot, let's not think about how we're going to get the slot yet, but this is the way, this is a good way to structure it. We have to figure out where is the slot we're going to insert it to. If we found a slot, then we're going to say things slot is ZII'd. Things slot dot kind. Do we have a kind? We didn't have it. Is going to be a kind. So we will have a kind.
We have traits now.
Yeah, we're
don't
not
have
gonna.
kind.
Yeah, we're gonna do kind. Kind is easier. Traits is sort of like the more abstract. Everything is remove code branches entirely and just or whatever. But this is easier to think about because then we have players, we have trolls. It's gonna be good. Okay, so we want to set the kind. And if we don't get a slot, what do we do? Like, well, we want to return from this a thing IDX. Right? Because what I want to type is be like, well, great, I added a player, but how do I keep track of it? So what I want to do is like static thing IDX player IDX. I want to do something like this, where like, and I initialize player IDX is this, and actually this is more like in the reset. So now I have a player. I don't really care what the trolls are. We'll update the trolls later because the reason I want player IDX is like during update, I want to be like if button left things dot get player IDX dot position plus equals speed. Something, this is totally not production grade, but like something like this, right? So we want to get the player and then like change its position, right? I don't want this to crash. Don't want it to crash even if the player's dead or whatever. So here, whenever we added a thing, we will return the slot. But if we couldn't add the thing because we were full, we're going to return 0. And the reason for that is because if the player accesses 0, what's at 0? Well, there's nothing at 0. It's zeroed out. It's a nil value. So when we do, this would be the well, let's just do refs. So we're gonna use some references. So when we do get, if we get the IDX, right? Here we can do something cool. If IDX is greater than 0, because we don't want the sentinel, and IDX is less than max things, then just return things IDX. Otherwise, return thing 0. And so,
okay. So now we have get for the things, and then we have add unfinished, right?
finished, yeah.
Okay, because we don't have the
We don't know how to pick the slot yet. So
Okay.
we'll get to that. But an easy way to pick the slot is we know that, hey, We just got a bunch of stuff. We start at the next empty slot at 1. We keep the 0th one there. And then the easiest way is if next empty slot is less than max things, slot equals next empty slot, and then we bump the slot. So if we have any empty slots that are unused in the array, we'll just grab one. If we don't, we don't. What's going to happen? Slot's going to be 0. When slot's 0, what are we going to return? We're going to return 0. If someone does a get of 0, what are they going to get? They're going to get back the nil. How do we know they're going to get the nil? It's going to be 0 initialized, and the kind will be set to nil. So that's
Fair
pretty cool.
enough.
Yeah.
Fair enough.
Yeah. So that's a thing we want to do. The question was what, of course, happens when we remove. So we're going to have a rem, right? So like void rem. So let's say we remove something. Now, same kind of thing. We want to make sure it's in the valid range. Otherwise, nothing to do with nil. So if you try to remove the nil, nothing, you can't do it. Otherwise, okay, we're going to need to return the slot back to the slot map. So here, we're going to need another array here. We don't need, this is not static thing. We have a bool used, again, max things. And by default, they're all going to get set to 0.
So to false.
So false. So none of them are used. And so when we remove something valid, we simply say used idx equals true. Oh, sorry, false. Whenever we add something, used slot equals true. Now, nothing else needs to be done. We don't need to free the memory. We don't need to destruct the thing because we're not doing destructors. If we have to do destructors, things get nasty because now we have to call the destructor manually, blah, 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 blah. Don't want to. So this is why this approach kind of like, once you buy in, you're bought in on a train where it's like, if someone comes on your team and they're like, let me add a std optional to your array, and you're like, doesn't work. We're not calling destructors. Like, what do you mean we're not calling destructors? You can make it work, but you know, don't do it in your log cabin if you don't want to. Like, buy in and try it out. See how it goes. Because if you don't, this is waiting for you. Oh, the horror.
Don't call constructors and distractors in your log cabin.
Yeah.
Like, it's simple. It's
Simple.
a simple rule to follow.
This is kind of why in the other stream, somebody asked about like 0 initializing stuff, and we were like heavy in constructor world. I'm like, there's no point, because where ZII helps you is in this kind of world where you're like, oh, look at all these assumptions I can make. I can make assumptions that like used as false. Now, a fair enough critique of that is like, if you're not in that mindset, the assumptions aren't written anywhere. So you're like, oh my God, it's uninitialized. It's like, no, it is initialized to 0. So you have to kind of like assume and lean on it and trust it, like those trust exercises where you fall backwards, make sure that you get caught, right?
But that's like, you need to program in a way that like you always can get these 0 values, these nils,
Yes.
and you need to handle them. Like, instead of hunting for a null, like the literal null, you're sort of hunting for 0 or nils.
Yes. And so but there's a subtle difference here, which is that, let's have a look. Let's imagine that we had a different kind of API, which gave you which gave you a pointer back. So right now here, my get carefully returns a reference, not a pointer. So for example, let's imagine we had an API which was thing player equals things.get player, player IDX, okay? So let's say that the get returned a pointer, and it could have been null, right? Because maybe the player's dead or gone or whatever. So then we have to say if player, pause, so on, right?
Yep.
So you have to check. In our world, we can just do thing player and we can just do player.pause. Now, what's that gonna? You're like, whoa, this is weird. This is a bug. It is a bug, but you can check for nil. Say if player. I'll show you how to do that, where you can make the reference return a bool. In fact, it's easy to do. I said we're going to override some operators, so let's get to it. So in thing, we can do operator bool const a return kind.
You're
Not equal.
overwriting.
I'm doing it.
Overwriting and
I told
overwriting.
you, I'm not. I ain't scared of C++. We can do this.
Wow.
Sorry.
At this point, you're one leg in the modern C++. Look, where's your book for design patterns? Okay.
It's
Where's
probably on the shelf
observer?
somewhere. I might put it in the closet.
Where's
This-
observer in this code?
I
Right.
know.
Here it
There is no observer. It's quantum mechanical. Yeah, and I'm leaning into all the features, man. All the features. We're gonna have references and ZII. We don't care. This is our world. We don't answer to people. So here, look. If you have this, all of a sudden, when you return a reference, you can do that, because that overloads to a bool, just like pointer does, hand wave. And so you can do this kind of thing. The difference is, if I leave this out by accident or whatever, I now crash. If I leave mine out, I don't crash. So when I want to be fast and loose, I can be fast and loose. And yeah, I'm hitting nils. It's all good. Like,
I'm hitting them.
it's my nils. So what happens is everybody hits the nil and they get this like thing 0, and everyone's like slamming it with values that are incorrect because they're assuming it. They think their reference is good, but it ain't. And so they're getting nils. So you can, it's kind of interesting because you can just ignore it if you're in a cabin, or you can start to say, well, you know what? Whenever you get a nil here, assert if nil isn't 0-ish anymore, because that implies somebody naughty wrote to the nil, right? You know what the value of nil should be. It should just be all 0. If it's non-zero, somebody wrote to it. You still return it, or you can memset it to 0, and then like afterwards, memset things. Things 0, size of thing. So you could do that and then clear the nil every time you return it, just in case. I mean, you can do this if debug, so that there's no performance implication. But the crucial thing is that if you have a bug in your code and you ship it to a user, my version won't crash. If you run out of memory here, like this thing, like why is this player null? Like, let's list the reasons. Could be null because index is invalid, or it could be, player's dead, or it could be ran out of memory. All these things, right? First off, you can't even tell. So now you're saying, oh, well, I'm going to return a reference and a condition of like what happened. It's like now in your game, every call site in your game logic that wants to do this has to handle out of memory errors, player errors, whatever. Whereas in my version, you never have to handle memory errors because it's fixed memory up front. And even if you run out, you just get a nil. And then you can drill down and you can say, okay. If the player is good, we do the thing. But otherwise, okay, let's drill in. Why player is gone? Is there not enough memory? Like, should we pop out or what?
Yeah.
So,
That's just like a tangential reference that like I understand that you have this mindset that is very like maybe not like console specific, but like ship software on a platform that you don't control specific, meaning like
is there
PC.
any platform we control?
I mean, for large chunk of the web dev world, it's like if there will be a crash and we ship it, it will fail on the first container. Like the update, the deployment will not go through. Like your Steam things are visible, but not. So like, we will catch that and we'll ship another fix in like less than 11 hours, and like it's gonna
Yeah.
be all in good. And I know, like, I like your approach more, but just like my mind is racing through all the comments that will be like, yeah, but actually it's quicker to
But
deploy another
actually,
fix, and all the like the because the just like programming world is so vast now that there's so
yes,
many like other
there's
things.
lots of room in the woods for everyone's cabin.
Yeah. The cabins can be not made out of logs now, so
Yeah, they
it's
can.
it's this diverse.
I mean, I will also say weirdly that the idea that the container will crash and recover and restart and the whole like kind of Erlang style approach where you just like fast recover rather than deal. Ironically, it's similar philosophically because here I'm saying, well, you crashed in the memory, but we recovered for you by giving you a nil. And you better like, if you want to get better, but otherwise we'll kind of like we'll cradle you and there's a safety net. My safety net is just closer to the memory, but the sort of Erlang or Docker safety net is the same thing. It's just like we'll restart the whole app when you crash. It's like, okay, I mean that's a bit brute force. Here I'm like saying let's micro restart this loop maybe if you get a nil or whatever. Um,
What
so
I meant to say is that this argument will be convincing to one set of programmers and barely understandable for a different set.
can't win them all, man. You can just come visit my cabin. I mean, I think it's worth trying to see and program different ways and see what feels better to you. But there is, it's all about kind of shared context and things like we were talking about the circular lists. Like zero initialization is like you assume it and then you reap the rewards by running with that assumption. Circular lists, similar kind of thing. You assume that next and previous will always be valid so you can avoid some checks. Here, you can assume that the references will always be valid. So sometimes, I'll show you some bad code here. I'll show you some code from not
Secret bad code.
secret bad code that I want to rewrite in this way because you wanted like an example. Here's like some code.
Super small font, but if you don't, okay, now it's bigger, but you can also do, people in the chat mentioned this, Windows and plus. Try this.
I'm scared. What does that do?
No, I've done it. It works.
Didn't do anything for me. Oh God. Oh, big
No.
things on my monitor. No, man, I'm not touching this. No.
Windows plus plus, like C plus plus, just twice.
Big. Is it pretty big, right? Here, I can make it even bigger.
Why is it for you doing these big scary things? For me, it is not. Why Windows? Okay. You have the example, and by the way, we're like running out of time. Like we're out of time now.
We're out of time now. Okay.
So
I'll show the example, and then we can reevaluate our life decisions. So here, okay. So here's like inside evaluation of a function. I have a function. Function has a kid, which is like the arguments or like the name of the function. The kid has a kid, which is like the symbol of the name. So this is like a parser evaluator thing. And you have these things where you're like, look, I hope this thing has a kid, and I hope the kid has a kid, and I hope the kid of the kid has a type, and the type is this, right? All this stuff. And I'm asserting it because I'm like, I just wrote this code. And mentally I'm thinking, man, I should have written it in terms of nils, because what I'm ultimately going to try to check is this type, right? Or I'm ultimately going to check this kid. I don't actually care about the first kid. I'm talking about like kids and siblings because it's like an abstract syntax tree. So really what I want to just write is like if function, might be something crazy like kid, sib, kid, type equals number, right? I want to just write that. Now, all of these, it starts to get nasty because you're like, well, does this thing have a kid? Did I have to do these asserts or I have to do these things? But I could just write this. If all of these are nil, 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 by the end, the type's nil and the whole thing works. So I save myself a whole
Nice.
lot of
This is
things,
super cool. And this is
right?
one thing that people complain all the time about, like, hey, I need to check for null for everything. So if like errors as return values, then you have like five things and you need to five if statements. And it's
Mhm.
like, and people start to wrap it with this like optionals and like whatever.
Exactly.
Nice. That's super cool feature.
Yeah.
Now
So
I'm bought into now.
you bought in, right? And then obviously if you're not checking the type, maybe you need to be checking. If you're checking a zero-ish value, this always works because you know, again, by ZII and because of nil mindset, zeros are these special values. So, but if, for example, the check you need to do is like health equals, 0, you can no longer do that check because the nil might have a value of 0, right?
Yep.
So there are some checks you can do and some checks you can't. So it's not a silver bullet in a way, but it sure saves you a lot of typing. And if you ultimately, this can just become this. Even here, it saves you because you can just do this. Let's say if I have this, right, then I'm going to check this. And this whole thing as a compound statement ensures that this is true, this is true, this is true, this is true, this is true. Or like valid, 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 valid. And you keep drilling
Yep.
into the valids instead of having to check each one independently. So it still wins you even if you have to check a zero-ish value. So,
Nice. Okay, there are some like extra questions, by the way. But let's stay on topic and let's decide what's going on. How far we are from the true ending.
well, here's the the question. We could either answer more questions and I can write more varieties of code, or I can slap this into a simple game renderer harness I prepared, which is just like draw sprite, and we can see if it compiles and we can get a game running. What does the chat want to see? Or what do you want to
Okay.
see, Wukesh?
Of course, I would like to see sprites running around the screen.
Okay.
But then my question is, are we missing something in the code now?
Probably. It probably won't work. We'll probably have to fix some things. Well, no, the main thing we're missing is that when we remove things, right? Right now, we never reuse the slots. So I did this used thing and we remove it. There's a couple of things we need to do that we didn't do about that thing. So first off, whenever we do a get, we not only check this, but we also now need to check and used IDX. So we want it to be used. If it's not used, we want to return a nil as well. And then when you remove, we also actually, when you remove, want to make sure it's used. In this case, it doesn't really matter, but just to be sure. And right now, when we get the next empty slot, we don't reuse our unused slots. So actually, the reason I set it up this way is because we could say, well, there is a way to
check for unused slot in the beginning.
yeah, so like either you can for loop through all the slots and find an unused slots. That's pretty slow. The way that I typically do it is with a free list. So I would do thing IDX first free, and I would implement an intrusive free list. So I would have this kind of thing. And so I would have a first, whenever I remove something, I would add it to the free list and then remove it from the free list, that kind of stuff. I can write that, but it'll probably take a good bit of concentration to get it done. So we can do that, which is interesting. That also leads naturally to what happens when the slot is reused and somebody's holding a reference to the prior version. So for example, you can have a thing like I add a player and then I'm like, remove a player.
But correct me if I'm wrong.
Yeah.
As long as you don't exceed the limit of 1,000 things, we're in a good spot to run it. No?
Yeah, it won't crash.
Let's do it then.
Let's do it. All right. All right, let's grab it. Grabbing it.
So that's the true ending I was
This is the
referring
true
to,
ending. We're going for
without
the true
without
ending.
spoiling. Okay, this is like whether the code that was happening on screen is actually compiling and working,
Yeah.
or was it like a philosophical exercise?
So I've
And
got oh, go ahead.
I'm not gonna put pressure on you, but like your credibility now hangs on this.
Godspeed. Okay, so I basically have this basic SDL harness. So let's see. Let's start by running it and seeing if it crashes. Um, okay, so yeah, here we go. We have a black screen. Um, Here we can change the color to make sure that we're not totally bad. And in fact, what we'll do is quickly we'll get into like a live reload loop. So all this is like I have some input handling. So if input's pressed R, we're gonna game reset. I'm loading a sprite sheet. Here's the sprite sheet. There's all sorts of cool monsters in there and things which we can use for our choices. Um, and yeah, there's like a game init that's gonna get called once, and we should probably call game reset from there. And we have an RNG, random number generator there. So let's just like grab it and go. So we'll have our kinds. We don't need traits. We have that. Look, we already have some bugs. Oh, it's kinds. Kind. Look at that. Okay. This is all stupid. We'll just get rid of game update. Don't need it. Okay, and this is our game reset. So we're gonna have our things. And then we're gonna reset our things. And yeah, we'll do that. And we'll add a troll. We'll grab that, put it at the end. Game reset, game reset. We don't need that. Where's thing IDX?
Like to me, the redefinition of an int for the sake of like type for your handle
Yeah.
is like too much. Like
Too much?
for
Oh
me,
man.
I would never do it. I would be like, hey, we just use ints, and by the time we want to switch to like long for them, nothing's gonna work. Like you will still need like in this like huge code base that we have.
We could do
We're
that.
gonna have so many columns.
64-bit int will get you a long way.
But like at this, what I'm saying is like this type dev thing assumes that like at some point in the future, you can switch and you can just switch this thing
Oh
and
yeah.
everything else will work. And I'm saying this everything
It's
else
bad.
will
You're right.
work part is
Yeah.
never gonna happen. Like you
That's
will
funny.
still
Yeah,
like
yeah. I
spend
don't think of it
weeks.
that way. I just want to type thing IDX, and I'm like, what's the fastest way? This is a one-liner. Let's roll. That's how I'm thinking about it. Does not imply anything. Just want to type thing IDX. So you could leave that as a code warning. But actually, in a more production version, we would use thing refs, and maybe if we have time, we can talk about how that's going to go down. Because these are what we need to handle, like recurring references and things. So what is that?
In the meantime, I'm doing a poll on this type dev thing because people are saying like, no, I am hugely mistaken.
On the
Do
type thing.
do we like type dev IDX int start poll?
Okay. I mean, I would actually. So what Dreams did, and what I would probably do in production, is I would actually do struct thing IDX in whatever, because that will actually give you real type safety. Because if you use the type def, it doesn't actually give you any type safety, and you'll be able to send it into an int. It's like, don't do that. So the only reason, part of the reason I'm doing is because I know that the end goal is actually a thing ref, but I don't know if we'll get there. We'll see. Okay.
Okay.
So let's see. So we have a player. So one thing we need to do is we need to render these things. So here's our render API. We have render sprite row, sprite column. And we have our sprite sheet file. here, and I put these like handy letters A, B, and K. So let's see, like, let's see. Let's actually open. I probably shouldn't do that. Okay. Basically, do you have a preference, Wakash, for the kind of player you'd like to be? Do you want like a mage
Can
or a
you
bear?
press Windows plus plus?
Uh,
Oh, perfect.
okay. What do we got?
The wizardy guy.
Wizardy guy? Like
Yeah,
number
like
12, A12 or something?
12B. Is this
12B,
9B and to the right.
9B, yeah, 11B. Oh, 10B, 10B. Okay.
Yeah.
Okay, how do I get out of this? Oh God.
Oh,
Okay.
yeah.
Okay. So we're gonna get you a wizard. So sprite B 10, you said? OXFF. What color do you want to be? You have a color, favorite color, Wakash?
Favorite color? No. Do you know how to do orange from
Yeah,
RGBA
sure. We
in
can do
Hex?
orange.
Damn.
There we go. Oh, a little bit less
A little
blue,
bit
less blue,
yellowish.
less blue. Oh, it's too yellow, too yellow. Um, 6 hours later. Okay, there we go. All right. Wakash appears in the chat. There you are. Is that readable?
Nice.
I tried to blow it up a little bit. Okay. So one thing I didn't really talk about is we need a way to loop over all the things. And so right now we could, because we want to render all of them, right? We want to render our player. So we want something like num things,
But
right? And then we blah, blah,
but
blah.
first of all, it works, right?
Well,
Like,
nothing's hooked up. I'm just drawing a sprite just to make
but
sure the renderer
the
works. But
thing is
oh, it
added.
compiled. Yeah, it compiled. Yeah.
Oh, it's not like looping an array and drawing each
No, it's
thing
just
yet.
drawing.
It's just drawing
Yeah.
a sprite. Okay.
Yeah. So to loop the array, there's a couple of ways we can do it. So like, here's the easy way. So this is the, I'm going to reach into the guts, right? So we have things. Well, we don't even know. It's like I less than empty slot. So we would have thing t equals things I, right? And then if not used, I continue. This is gross, just to be clear. We're gonna get rid of this, but I just want to show what's kind of going on. And so here we'll take the t position, and we don't need rotation yet. And so for now we'll just
Everybody's triggered by the fact have capital I.
yeah. I'm trying the style. I kind of like it. So I kind of like it. I'm not going to discuss style because then we're going to be, but capital I, I'm kind of feeling it. I think I saw Casey use it. I'm like, damn, that's
I love
fresh.
the comment. I love the comment. Capital I. This guy different. No verbs.
I took it from Casey, so it's not. I'm just trying it out. So I did like a merge of what I do and what he does because I think he has like camel case functions. I like snake case functions. Anyway, whatever. We're not gonna go there.
It's your cabin.
It's
your
my
cabin.
exact. Now we're talking. Okay, so here's what we want to do. We want to do like, we want to put our money where our mouth is. So we want to be like, if thing player equals things.get player idx, right? So if we get the player, we want to do player dot position equals something like this, right? So, and let's make it different. So when we initialize stuff, we add a player and then we get the player and we put stuff in there, right? And here we should be looping over all the things and rendering with sprite B. And I can't live edit on that because I just added a bunch of variables, but it's okay. Compiles fast. So there we go. There he is.
Nice.
And here's a cool thing we can do. We can actually pin the window. We can do like 180, live recompile, reset, and there he is.
Damn.
There he is. And so now we can say,
This
let's
is live recompile the Visual Studio feature.
Yeah,
right?
yeah.
Okay.
It's good. So people like bag on live recompile in Windows, and it does crash out a lot. But if you don't do any vectors or C++, it's pretty good. So if you just stick to this kind of code, because it's not because they're like, forgetting the engineering opinion you might have, it's hard to deal with pointers. So we're not doing any pointers, so it's all easy, and so it works. Okay, so let's do some movement. Okay, and by the way, this is a kind of thing where it's like, look, we added a player. I know I just added it. I'm doing the game reset. If my game reset fails, we're not gonna get anywhere. So why do I need to check it? I don't need to check any of this stuff. I don't need to check if it's true. I could, but it doesn't matter, right? Or I can just do this. And there, I save myself a line, and I don't have to do error checking code in here, because if things go wrong here, it's a mess anyway. So, but here we probably want to. So we do like if thing player things.get player IDX. Okay, so now we will do if inputs is down, input, let's see, W. So, in fact, let's just do this. Vec2 delta is, so we're gonna basically move the player around, right? Because we don't want to like just stand there. It's not interesting. So if we do horizontal is D minus A. So input D minus input, whoa, clipboard. Input, I'll move this to the side for a sec. Input A, this is kind of a cute trick. So you can do, and then I think we're upside down because I'm doing pixel coordinates for simplicity. So we just do this, and then we do player.position plus equals delta. Whoa. Syntax error. Why? Oh, here. There we go. No, I don't want to stop debugging. Rebuild. Stop. Oh, just this brace. Okay, here.
Tons of errors. Now,
these errors, man. These errors. But it's all right. We'll get there.
no, now the code.
Oh, this is a Vec2. What is this? What am I
I know you're missing, but
yeah, we're good. We're good. We're fine. No big deal. It's converting from. Okay, there we go. So we're going, and that's kind of gross. So let's get rotation in there, because I think we need some like. Here, I'll show you all a quick trick. And time. Okay, so watch this. So you can do player.rotation is equal to sine player anim time. And then here you do t.rotation. And then just in general, whenever, actually, player.anim time plus equal 1. Let's see how fast that goes. And then basically, so here's what we're going to do. If we're going to wiggle, if the person's moving at all, then we're going to wiggle. Otherwise, we're not going to wiggle. So if, what is it? If any del if any is not equal to 0, we're going to advance the time. else player and time. Will that work? It's probably gonna go bananas. It's gonna be funny. Oh, what?
So does it
Oh.
wiggle?
Why is it not? Are we hitting this? Okay. Anim times. Oh, is it just too fast? What? Okay. Rotation. Is rotation? Sine. Oh, I see. It's probably like SDL is in degrees. There we go. Whoa, whoa. Bananas. Okay, let's see.
Okay,
45.
Anton, you should.
Okay,
we
okay,
should
sorry,
s-
sorry.
We should wrap up.
Okay,
soon.
let's add some let's add some like actual like other entities, right? So let me show you really quickly how to get rid of this garbage by doing an iterator. Is that a good idea? Because you don't actually want to reach into stuff and cycle through stuff. Or we can add more entities. What does everybody want to do?
I would say we should add more entities and call it a day.
Okay.
To have a sort of digestible
Sounds good.
video afterwards.
Struct thing iterator. Iterator is going to have things, my things, and thing idx. So to properly do things, we will do thing iter begin return myself and starting at 1. Thing iter end return this max things for now. So we can return these things and then we will on this thing. How do you do operator plus plus? Anybody know? There's I might have to look that up, but basically, well, I don't know if I want to put people through this. Basically, the idea is you have this, you move this whole loop into there. So you skip over use things as you iterate. You can define like the arrow operator so you can actually access the things. So
we would abstract out these parts of the loop so that every
yeah.
time you iterate over something, they're happening.
Yeah,
and
so
people
you
have
don't
to think about
yeah, that way you don't have to do this like gross, like reach into the guts things. I mean, I like the structs because as I prototype, I can kind of reach into the guts as I want to, but I'm not going to leave it like this. So maybe while we answer Q&A, I can actually look up how to do that iterator. I think I looked it up before. But you can do that and you can get rid of it. The other thing is that when you there was used to be a good Our Machinery post about how do you deal with like referencing the same point, but basically you add like a generational ID and you keep track of it. But then all the Our Machinery posts disappeared, so I don't know anybody who talks about it anymore. Maybe that's why nobody talks about it, because their blogs disappear if they talk about it. But yeah, you add like a generation thing here. So I don't know, maybe we can, if people are interested, I can drop the kind of final version of the code later on, or we can spend another half an hour while we answer questions. And
I feel like if you want to put something like from this online, then you can do it like in this version. So that like, because sometimes people are like, so here's this like super simple version, and then I'll just clean it up, and then there's like this giant thing that it like has
no, I would do it from here.
5 arms. And
let's get some trolls out there and see what the performance is like. How about that?
Trolls, fair enough.
What about?
Then if people have questions, then again you can add me, and we're gonna follow up with questions in the closing section of a Q&A. Because we're going on for 2 hours and 20 minutes now, which is, I mean, yeah, it's more like 2 hours and 10 minutes for the parts that we are now. We've been large arrays of things. There is also an archive of the Our Machinery blog posts.
Oh
Is
yeah.
it?
Okay.
Is
Read
it?
read about the slot map. That's where you can learn all about this stuff.
Well, are you sure how you can access legal or not? Our
That we don't know.
Machinery blog. Mm, there is there is a GitHub page with this. Interesting.
Oh really? That's cool.
It's actually, yeah. And I click various blog posts and they are there.
Oh, there you go.
Or not all of them. Yeah, some URLs are not found. Interesting.
It's a good troll sprite. Whoa. Troll. It was a werewolf. G18.
What is the name of the program you use for sprite sheet?
This is Graphics Gale. It's really ancient. I was gonna use something else, but all the other ones are on web, and I don't want to like shill Adobe products or anything. So this is what we're doing. Let's see. Do we get what color should the what color are werewolves?
Color for werewolves? Something distinctly
Probably.
different from orange, no?
Yeah, probably gray, right?
How uneventful, how like unimaginative of you. You work at a creative company.
Oh, okay. They're gonna be green, blue. You gotta be slightly blue. That's what I'm gonna do. 80, 80, 83. There we go. We're gonna be very tasteful. How about that? I'm happy to just answer questions as I poke stuff. I'm not like doing anything particularly
I feel like
complicated.
people are mostly spent. There are no new
What is
questions
happening?
coming up.
Okay.
There are new there were like a couple of unanswered questions when we were like deep into discussion about pointers and trees. At some point, I think the excitement died down. There are still people that are happy in the chat and joking, but I think that the technical discussion got the best
It's
of us.
completed. Do you have any questions, Mukesh? What do you think? You're gonna make a cabin?
I would like to try living in this cabin, yeah, for a little bit and see how this progresses. You know that like I am always on the side of like you're being dropped into a project that has like legacy software and you don't get to do this stuff. So this is something that it's for me it's a different angle. It's like you're creating a new project
Yeah.
and you need to have people that are technically inclined and they are willing to learn this stuff, right?
Yeah.
And as far as my experience goes, maybe a sad one, but most teams want to be on the defensive side, at least in my situation. So like if you say like, hey, here's like a new idea and it's gonna be
Yeah.
awesome, but we're gonna have like intrusive list and we're not gonna use things from standard library. They're like, they stopped listening. They stopped listening after like 3 words because they looked at this expression and like, this expression doesn't mean anything good for us. It's not safe. It's not like when you leave the company, we need people to maintain it. Like, and
Yeah.
you're already like in this discussion of like, okay, how we're
Yeah.
gonna maintain it and like, so that's for me that's the
Yeah.
danger. So log cabin, yes,
Yeah.
or like widely technical team
Yeah.
to that shares the same goals, yes, but or like Linux kernel, like you're the person who is maintaining a
Yeah.
piece. It's like your territory.
Yes.
It's C. You get to do this stuff.
Hmm.
Then I kind of understand it. But
Yeah.
it's I understand why it's not going to be mainstream anytime soon.
So the weird thing about that to me, like I completely get it. Like I've worked in big teams and all this stuff, but the thing I find surprising is that the the people that are doing modern C++ are also highly technical. Like I've talked to people who know way more about move semantics and shared pointers and all manner of like, well, actually details about C++ that I don't even know. So I'm not sure technicality is the thing that's lacking. Like I don't think maybe a certain kind of technicality that's more centered around um, memory management and things like that, maybe. But honestly, I find modern C++ way more complicated than what we just did um, in terms of like having to deal with that problem. And like, hopefully now it maybe you got a sense for like why in the other podcast I was like, as soon as we get into some C++ stuff, it goes off the rails pretty quickly in terms of the kinds of ideas that I want to apply. Because like as soon as you have multiple arrays, like you can't mem set things to zero anymore. As soon as you can't zero initialize, a bunch of things go away. As soon as nil is not a thing, things go away. So a lot of things kind of go away. And so when you get this code base, which is like maybe a heavy C++ code base, and you're like, how would you improve performance? I'm off. I don't even know where to start oftentimes because I'm like so many of these tools were already removed that if you use any one of them, it doesn't get you anywhere. It just looks weird, right? Like if I went into a code base and like, I'm going to replace everything with indices, like, whoa, why? It's like, well, wait until step 6 when I sort of remove the concept of nulls and bad pointers. Like, no, but for now it looks really bad. And it's like, well, so there's a valley of sadness, I think, before you come out. There's like, even if I imagine that, okay, modern C++ is a sort of hill where memory safety is a thing and whatever, or like Rust, to get from there to like here, you go through this valley of bad C where it's like crashes exist and memory's unsafe and there's no types and all this stuff. And I guess what I'm trying to say is if you keep going down that hill, you can get back up to a similarly high quality hill where you don't crash and it's fast. The whole underpinnings is from a fast perspective. So the other thing I didn't show was like how to make sure this thing scales because we put structs everywhere and it's just basically fat struct. But actually, kind of related to the other question was how do you do dynamic members? It it actually helps performance to rip the struct apart into a bunch of arrays. So instead of having one large array of structs, you instead have an array for each property. And the reason that helps is because in cache, as we saw, like the structs are getting laid out in memory, and every struct is sort of a huge thing, one after the other. And when they start to get big, like on model or on dreams, these things are, they could have 100 members and they're large. So actually at that point, when you're accessing them, you're getting cache misses as well because half the properties are being unused or more. And so the way to do that is you start to rip it out by property. And that's kind of what traditional ECS does too. You rip things out by component so that the array is tightly packed full of stuff. And then once you do it that way, then adding properties becomes this like more mechanical thing. And you can do neat things like whenever accessing a property, you can return a default value, or you can error or log if an entity doesn't have that property, things like that. You can start to kind of build that up. So this is the really bare bones version where we don't really care about things going wrong, but you can actually add bits and say, oh, trolls don't have health and whatever. Like you can kind of lean into that
I
side of things.
I feel like that's maybe the general difference uh, is that you always think about like my platform, like let's say I'm on operating system and like I'm creating an application. So like everything that I do, like all code is up to me. Like this is my base layer is the
Mm.
platform. And for I already come from the like this newer kind of thinking where like you're supposed to use standard library, you're supposed to use the framework. And like after years of like unlearning this and understanding that you
Yeah.
can do whatever you want on a given platform, like that's up to you. Now
Yeah.
there's like tremendous number of options that you have, so like you don't need to pick like either it's an engine like Unity or like a framework like React. Like you can do whatever you want inside
Hmm.
the process, and you have like entire operating system if it's PC
Hmm.
to like facilitate what you want. So now if you want to have an intrusive list and everything defined by that, like do it. That's up, that's your decision. Like,
Yeah.
and then you get to do to make these choices. And
Yes.
but for like many of the programmers that I've worked at, like
Hmm.
a lot of people just like will remain on this level. So now the discussion is like, why would you go lower? You know, like why would you? And I like this because we get to talk about when this would be useful. For example,
Yeah.
for the ECS kind of style, what you would do, how you would rip out the properties and components and like manage them.
Yeah.
Wh- but for I feel like for the most people, if you ask me like when is the soonest I come to the your log cabin and then implement this in the workplace,
Yeah.
it's gonna be like, oh, it's probably like at this point never, because like I would need to first convince them, or like myself, to the point that
Yeah.
convincing them is good,
Yes. Yes.
to actually enter the discussion of like, let's drop the established framework in
Yeah.
favor of something custom. And
Yeah. So
that's all a huge step.
I think that's all totally valid. And frankly, if I was running a company and somebody came in and they're like, "Oh, I want to rewrite everything," like, I'm not gonna let
Exactly.
you do. I don't know who you are. Like, why would I do that? So like, either you have an established sort of reputation of knowing what you're talking about, and you get brought in because like, oh, like you cleaned up a bunch of compile time stuff. So like, if you came into another company and they were hiring you because they wanted compile times improved, presumably they'd give you some leeway to be like, okay, guys, we're not gonna do this and this
Yeah.
and whatever, right? So you kind of build some of that. Second thing is that there's naturally cycles in a company when they want to rewrite something from scratch or redo. Like there's enough appetite that they're like, man, this system is just too slow. Sometimes it's a self-contained system. Maybe it's not the whole thing, but maybe just like the logging server or the metrics or something, right? So something small you can kind of chew at. And then lastly, sometimes the market just forces them to reevaluate performance. Sometimes a tool comes out and it's like just 10 times faster, and everyone's like scrambling. Like everyone is totally fine living in whatever slow slop land that they ended
Well,
up in,
you
and
know,
someone shows up and
RAM prices just spiked.
right. So maybe,
So
so there's going to be forcing functions that sometimes people go, wait a minute, okay, now we care. And it's like, okay, well, maybe I cared earlier before other people. Maybe Casey cared earlier or whatever, because he's like, oh God, everything's so slow. I wish it wasn't. And I was like, it's fine. Market's fine. But, he mentions times of like when Facebook rewrote stuff for performance. And so whenever those beats happen, you can be like, hey, you know what's fast? Arrays. And people are like, what? And then you can kind of like that's the in, right? And yeah, obviously it's not gonna land until people want it. So I think performance is like the inroad, but I guess what I'm trying to also show is that it doesn't have to be the end result. Like actually there's a way to do this with performance and have the safety of smart pointers or things like that. And actually, if you kind of keep going down this road and read the Our Machinery articles about like generation IDs and slot maps and all this, it actually ends up being better than smart pointers in terms, in my opinion, in terms of like memory safety and debuggability, because now you can set breakpoints based on concrete things. You can make assertions about your code. And we saw with the intrusive trees, certain states become invalid that would have otherwise caused bugs. There's a whole bunch of little things where actually like not only is it faster, you can actually also write better code. And hopefully people will get there. And then it's like another um, piece of candy at the end there to get to. Not just the old C kind of, I just do arrays for performance.
but that's the one thing that I also keep noticing, is that if you go this way and you just use arrays, often like fixed size arrays, you use structs, you avoid when you avoid this C++, modern C++ thing, you tend to just program because you know what you're doing. You have an array, you know how to access thing, and you have a struct, and you know the members. And if you use the standard library, you have like, okay, how do I look up thing in a map? And then you
Yes.
Google this or you chat GPT, and there's like this huge thing, and like,
Yeah.
okay, maybe this is not, but oh, if you have C++20, uh, then you have contains in the map. But for
Mm-hmm.
string, you still need to do
Yep.
find, and
Yep.
find is gonna compare to end parse. But in map, it was dot dash dot colon colon end, right? And
Yeah.
you
Yeah.
need
Yeah.
to know this. And like,
Yes.
but
Yes.
C++23 actually has contains for string, and it's like,
Yes.
Jesus, it's just too much, you know. And at
Right. Right.
some
Right.
point, they're like, but here, like, hey, this is my kingdom. You know,
Right.
you have
Well,
a
it's funny.
struct, you
Yeah.
have an array, and that's it, you know. And
Like
now
we,
you program, you
you
solve
could
problems.
exactly. You could see it live. Like we were rolling until I was like, let's make an iterator, and I was like, what do I? How is
Yeah,
that? How?
exactly.
And it's
This
like
exactly.
boom. And then now I'm like, I'm not gonna go on web, but like clearly that was a stopping point, right? And imagine if you're always in C++ land, that's
Yes.
happening all the time, constantly, right? Whereas here we were able to program for like 2 hours straight.
And then you like C++, and then you add like a framework like
Right, right,
Qt, and then you
exactly. Yeah.
add another framework for something else. And now we're like framework land plus C++
Yes.
land. And it's like you're barely programming at this point.
If this is what we call, if what we just did was called, which was what I would call like architecture and programming, like how do we arrange these things? How is the shape of the memory going to be? How are we going to connect our entities or things? How, all this stuff is what I sort of think of as programming. Now, it's definitely like a no true Scotsman discussion, like, well, real program is, I think it's all, there's application development, which has not much to do with this, right? Which is just like, I'm gonna, you know, glue this front end to this back end to this thing. And it's like, okay, now we have like an app that does this useful thing and that's viable and people need that stuff, right? But that is of a different character than this kind of stuff where you're like, okay, we need a new data structure that's able to support like addition, remove, like it's basically like writing the standard library kind of stuff, right? And so there's a reason why people don't reach below the standard library because it takes a different kind of mindset and thinking, right? But hopefully this also gives us a show of like, hey, you can make your own data structures. Because here's the other thing that's subtle, but maybe is worth pointing out. We talked about intrusive lists and how they go into, into the actual object. But also when we added this things, like this is not a vector of things. This is like a things data structure, right? And you can abstract this to some extent and you can say, well, actually, like I've actually in some of my code, like I've called it a thing pool, and you can actually have like a monsters pool and like a, you know, rocks pool, or what, you can separate the pools if you want. So you can abstract this into a reusable thing, but you could also just say, these are my things. And this is like effectively a database, like in other parlance. It's like you can add things, you can remove things, you can iterate them. But we're not like wrapping a structure around it that's generic. We're building the whole thing as a unit. And then we use it generically, right? We add trolls and we add things to it. And this code starts to look like normal business logic. But this code doesn't look like STL style code where we're composing containers. So that's another subtle thing that's going on. The mentality of STL is like, there's all these building blocks that we've given you, like vector and map and hash map and pair and tuple and all this stuff. Assemble your data structure from those blocks. I think that doesn't work. I think that's like a bit of a failed experiment because from performance standpoint, it doesn't really work. Everyone knows you don't want to have a vector inside a vector for a 2D vector. So then you have 2D vector and 3D vector and template this and template that. But you could also just write the thing. And the number of things you will need to write is maybe like a dozen for a game or something. Like you might have your things pool and your sounds might look a little bit different, or maybe it's the same. But it's not like an infinity of things. And I think the idea with STL was like, well, here's the building blocks and there's like 30 of them and you can build the infinity of things and they will be performant and nice and safe. But actually what it turns out to be, in my experience anyway, it's more that if you build the few things you need as systems that contain the management of of all of it, that tends to be easier code to read. It tends to be more performant. And then your business logic still looks clean. It's not like it starts to look crazy and unclean or whatever. So it's kind of like saying, let's glob the data and the data structure into one thing, as opposed to the STL method where you say, well, there's a container and the data, and they're separate, and they must not know about each other. And that's where the intrusive list, all these things kind of. So it looks messy, but I don't know, maybe reconsider. Maybe it's less messy in the end if you compare end to end the result of one versus the other. So
All right.
some werewolves.
Nice.
Yeah.
Okay. So let's finish this then. This was another live coding session. Third one on this podcast. Second one with Anton. There was one with Ginger Bill on Async.io in Odin. The first one with Anton was on like focusing more on return values when I was throwing like a medical problem, med tech problem on Anton of image registration. And this wraps up the episode on the state management, hashtag large arrays of things. It might be that we might come back to state management in the future. This episode will be available for members on YouTube and Patreon immediately in the unedited version, and will be available for public in something like 4 or 5 weeks ish, probably like early February, because things take a lot of time to edit and release queue is big, which would be early February for public release probably. Are there anything? Yes, okay. Thank you, Anton. This is the one thing that I should do. Thank you for joining and showing this stuff. This is a lot of interesting and cool techniques, and they are so rarely discussed, so it's nice to see them also live with ability to ask questions and interrupt and discuss, and they are all wiggling.
They're waving goodbye. This is the goodbye.
Nice. Nice. Thanks everyone who tuned in the chat. If you want to check out Anton's cool calculator that was showcased, it's like a calculator, but also has a programming language features built in, where you can pretty much define variables and functions and call them, and also visualize functions. That's also available. It's called Naut, N-A-U-T, at least for now. It's called Not, from Nautilus. It's available on Anton's itch.io. Do you remember the exact URL?
I think it's just like Antovsky/not probably. I don't know however itch does it, but it's like my Twitter
it's
name.
antovsky.itch.io/not.
It would be not, yeah. And
Okay.
Yeah, it's handy for this kind of back of the napkin stuff. That's why I made it.
Thanks everyone who tuned in on both Twitch and YouTube, and if anything is on X, also thank you.
Thank you.
Bye everyone.
Hope you had a good time.